Hi, my name is Henry Robinson. I'm Director of Product Management at VMware. It's interesting, I'm between you and alcohol, or something like that. So what I'm going to do is spend the next few minutes talking to you about Site Recovery Manager, talk about some of the futures. So definitely in this case here, it's slightly different between the word futures and roadmap. Roadmap would define what we essentially are pushing forward, and these are basically ideas that we're putting in place. Standard disclosure, anything at all that we talk about with regards to the future, not committed, we can't commit to schedules, etc. What we're going to do is talk a little bit about Site Recovery Manager. How many of you today have Site Recovery Manager implementations in place? Okay, good. So what we're going to do is talk about what exists today very quickly and talk about areas that we're moving to with regards to the future. We'll talk about things that we can do to improve the DR experience. We'll talk about how you can manage to zero downtime. Two pieces that people talk about when you start talking about recovery management. You talk about the ability of being able to have the recovery time objective, RTO, how fast it takes for you to recover, as well as a recovery point objective, which is at what point, what type of loss of data you will have. So we'll talk about how you get to managing zero downtime. We will talk about an alternative technology which fits within certain environments, and we'll call it a stretch clusters. And finally, we'll talk about how we move forward to the cloud infrastructure. Very quick recap on what Site Recovery Manager is today. It really is an orchestration engine that orchestrates the workflow that is related to disasters, right? In the case that you lose a site, then how do I turn around and ensure that those workloads can exist on a different box, on a different site? What Site Recovery Manager does is help you with regards to setup. So you select the virtual machines, you select the workloads that you want to fail over in the case of a disaster or in the case of any outage, and we'll talk about what those are. Two is, it gives you the facility for you to test. You surely, in those situations there, you don't want to try it at the time of a real disaster. You want to ensure that what you've set up would actually work. And finally, the third piece is, indeed, the tools that allow you to automate the orchestration of a true failover. What we're trying to do in SRM is really to turn a manual recovery runbooks into automated recovery plans. Some people now and then will say, all it is basically a bunch of scripts, a bunch of workflows. Can I do it myself? And what you're going to find is that all of the complex procedures that orchestrate the network, the storage replication, the vSphere infrastructure is all built into the product. We provide central management of these recovery plans. And so the important thing is that what we're really trying to do is, as you move towards virtualization, it gives you the ability of being able to move across and reliably fail over from Site 1 to Site 2. Real quickly on the basics, lightning is always the great one. The first thing that SRM does is it detects a site failure. It'll detect a site failure because I've lost storage connectivity or network connectivity. You'll initiate failover. Unlike high availability or HA, which is automatic, a disaster is something that requires user confirmation. Typically, most companies, you'll essentially have somebody who are pay grades higher than most of us who'll decide and say, yes, I would like to declare a disaster. The second part is you decide what type of disaster I want to have. You can have recovery plans in place that says, this is a network disaster, this is a full disaster, this is a partial disaster, and you define which recovery plan you want to start executing. The first thing that happens is that you manage the replication failover, which means that you have to expose the LUNs at the recovery site. You expose those LUNs to the ESX servers, and so you make them visible. You start executing the recovery process, and executing the recovery process will essentially start powering on the virtual machines on the recovery site. You use a pre-programmed plan, so you've defined all of that for you. And what you have is, in Virtual Center, you have the ability of being able to actually see exactly what's happening as it moves forward. So the result is you have automation for failover, you have step-by-step visibility. So that's today, and that's how SRM works. By the way, it does work for other disasters other than lightning. In a lot of cases, some of the disasters you have may in fact be disasters within your data center, such as power failures or those types of environments as well. What types of scenarios is SRM being used at? In fact, one of the things we're trying to do now is to learn more of that. There's a traditional one which says, I have a dark site, which is typically not available, and is simply used as my DR site. This is not typically used. Most people do a failover to an active site. The site is running software dev and test. You've separated out your workloads to 50% or 60% on one side or another, and they're protecting each other. So we see that as a good example of how do we deal with that. Software dev and test, by the way, is used a lot as a DR site. People will turn around and say, this is my staging machine, I will use that. Bidirectional failover, there are a lot of cases where, in fact, what you're actually doing is you have two active data centers, they're protecting each other. We have some interesting environments where, in fact, educational institutions will team together and say, I will be your DR protection site, you will be my DR protection site as well. And so, therefore, they can actually, with a small investment, actually provide DR where in the past they didn't. And finally, local failover, not frequently used, but it really has the ability, it's used in some cases where you actually have what are called fireboxes or fire zones, where in fact you actually have your data center compartmentalized that takes care of certain failures and so forth. So you actually have portions of your data center segregated. Okay, so enough of that, because you didn't come here for me to talk to you about NSRM and overview, or if you did, then that was a very quick one. Let's talk about, first of all, the future, which is what is essentially coming soon. And in fact, there are sessions that we're actually having which goes into a deep dive on these environments. And I'll give you some pointers as to when those are available, which is actually more detail than we're providing today. So the first thing you want to deal with is, I failed over. Then what do I do? At some point in time, depending on the type of disaster, I want to fail back. Two is that there are a lot of companies who are now turning around and saying, look, a disaster, I will not have a DR site that I will only test disasters. I actually want to operationally execute a disaster on a regular basis and fail it back to the original site. Typically true in financial institutions. Financial institutions want to prove this out. They don't believe the audit reports. They really want to say, hey, give me a real disaster. So what happens in automated recovery is, and again, it's the automated failback. The user initiates the recovery plan. I'm going to move things back. The first thing that happens is that the replication has to go in reverse. Now, one key part that SRM does is it works and orchestrates with the array-based replication in order to coordinate all of the replication. It turns around and will tell the arrays and say, look, start replicating the other way. You have a master copy, which is now, of course, at the recovery site. You want to put it back to the primary site. The next thing that happens is that you are starting to power down the original site. So in this case here, you're actually doing a soft power down of the virtual machine. You don't have a disaster, so you don't have to cut the power, so it'll be a soft shutdown or orderly shutdown. And then you'll start restarting them at the primary site. So what happens there is, and the order by which you can do it, you can define the priority, you can define the sequence, you can define the granularity across that. That gives you that ability. And then the last thing we do is cleanup. Once you have all the virtual machines moved over, then you want to do is reverse the replication, because now your master copy actually is at the primary site. And so we do this protection group by protection group that will give you the ability of now essentially running a rolling failback or a rolling failover. Okay? So it's automated based on your recovery plan. So it gives you that ability. By the way, failback also has the ability of doing failback test so that you can test this out before you actually do it. Okay? The second feature that we're going to provide is host-based replication. Host-based replication takes the use case that says, what if you happen to have sites that do not have array replication today? Okay? You are running your virtual machines on non-replicated storage or on tier 2 storage. You may have array replication for a significant part of your workloads, but there's your second and third tier workloads where, in fact, your recovery point objective may be less, where you actually just simply don't want to, you want to stay with the current storage that you have, and you want to replicate that, essentially use host-based replication. The second thing is, Site 1 and Site 2 have different types of storage. There are facilities available today, or there are products available today that will deal with heterogeneous storage. They're available through partners. What we provide is, this will provide essentially an ESX version of being able to take care of that from that side. The third piece, and perhaps the most important piece, is that you're protecting on a VM basis. Unlike array replication, where you're protecting on a LUN basis, which is a full set of virtual machines, in this case, you're actually protecting on a per VM basis. So your granularity of failover is at a per VM versus a per LUN. It may simplify things, etc. We expect two things in the first release. One is that it will be useful for a lot of customers where in the past DR or putting in storage-based, array-based replication may have been too expensive. It didn't make sense. Or two is, I'm now using it for my second and third tier workloads. There's actually a third piece which I think is important is, as people deploy SRM, then trying to connect the replication part of storage with vSphere has its challenges because you're dealing with, in a lot of cases, two different administrative teams. It will allow you to be able to try out SRM using host-based replication when you proved it out to yourself as being as working, and now I have my DR. Then you can spend time with the storage team and say, let's make use of the infrastructure you currently have. So we feel that failback and host-based replication is a key part towards increasing the penetration of Site Recovery Manager. By the way, before we move forward, there's another thing that we found. One is that we see the fact that SRM is an ideal tool for data center migration. And in fact, there's a recent report by ESG that showed that over 35% of companies today have data center migration plans underway. In the past, how would you migrate your data center, right? You'd turn around and say, I'm going to migrate some of the hosts, I'm going to migrate some of the applications. It's a very, very long, drawn-out process, which has a lot of error profiles on it. People have used, a lot of companies, and in fact, what we found is over 30% of the companies today have actually used Site Recovery Manager for data center migration. One company actually said, look, last year, right before Labor Day, I started my migration. My vice president pressed the red button. We went away for Labor Day weekend. We came back the Tuesday after Labor Day, and my 400 VMs had actually moved to the other data center, were totally online, totally running. Another example, and in fact, there's actually a session this week on this from Weyerhaeuser, where in fact they were actually moving from a company-owned data center to a third-party data center. The data center migration was going to be achieved by a third company using outsourced resources from India. Now, I cannot make this story up. This is a real story. And so what they actually did was the architects used Site Recovery Manager to build what was called the recovery plan, define exactly what virtual machines needed to move, and then they provided those specifications to the outsourced service in India, created the recovery plans. They would turn around and be in charge of ensuring that everything was fine, start the recovery plans, and the architect could actually see the migration of virtual machines real time as it happened. They did this for a set of workloads. They rinsed and repeated, moved the next set of workloads. So they were able to accomplish in a period of several weeks the actual migration from their own data center to a new data center using third-party resources. And then they turned around and said, now we understand how to do disaster recovery because we really have the tools in place, our understanding of how we move forward from there. Where are we going with this with regards to future directions? The future directions talk about one of the issues about data center migration. How do I understand that I have enough resources on the other side? So capacity planning and application mapping tools becomes important. How do you decide which VMs, which order do I need to deal with? Do I have proper amount of resources? That's important. As well as moving towards increasing the unit of failover. Failing over individual VMs is great and fine, but it's also very tedious. And so being able to say, hey, I have a cluster, I want to fail over that entire cluster. I have a vApp, and I want to fail over that other vApp, will really remove a lot of the manual operation that you need to do with Site Recovery Manager. Now we ask this question, why only failover, right? Where are we in the future with regards to improving the unit of failover that's happening, right? So in fact, what you can start talking about is managing the zero downtime data center, right? If you take a look at this, and there's been a lot of buzz around something called long-distance vMotion, which today we call vMotion Anywhere, which talks about, oh, we can move virtual machines 3,000 miles away. In fact, there's a demonstration by a storage vendor which talks about using long-distance vMotion over extended distance. Now, for most of you who are here, you'll know that a virtual machine typically doesn't like to live alone. It most probably has 7, 8, 20 of its friends that it communicates with on a regular basis. So the last thing you want to do is move one of them a long distance away, because in fact, in those situations then you're really going to have some issues. So there definitely is a case that says, I want to be able to move an entire set of virtual machines that's defined as your application workload. I want to move them over in a certain sequence. By the way, I may want to test that move before I actually do it live. I still remember the first time I ever went on the Autobahn in Germany. You can get lost, and you can get lost very quickly. So if you use that analogy, then vMotion Anywhere, which would be a very good thing, you want to make sure that in the end it is repeatable and actually is doing what you want to do. So what do we need to do? One is you have to have the ability of being able to design a migration plan. 2 is you need to make sure that that's correct. 3 is you have to deal with storage orchestration. It's great to say, hey, the way in which we're going to turn around and do vMotion Anywhere is we'll use storage vMotion. Well, storage vMotion is, moving all a 40 gigabyte VM from point A to point B. Sometimes it's easier to move it on a truck than it is to move it over a network. So in a lot of ways, by making use of existing technology that's there, such as making use of the fact that that VM is already replicated from site A to site B, may be very, very useful. And so all you need to do is actually move the deltas of the disk and then move the CPU and memory. Then, of course, there is this case that says if you start moving these VMs around, you better have a record of where they went and when they went there. And so one of the key parts is the migration details for tracking and compliance control. So a lot of the features that Site Recovery Manager has is very good as when you start managing sites. So what would start happening? So if you take a look at a standard migration, you may select a set of VMs that you want to migrate. The next thing that happens is SRM coordinates movement with its peer. They agree and say, by the way, I'm going to send you 3 VMs. vCenter communication, so vCenters start communicating based on SRM direction that turns around and exchanges the virtual machine's configuration info. For those of you who know a lot of details of the VM infrastructure, there's a lot of information that's stored in a VMX file. There's a whole lot of information that's not stored in a VMX file. the permissions, the backup policy. I'll forget a whole bunch more. But the point about it is you want to make sure that the VC can take all of that configuration information from Site 1 and give it to Site 2's VC so that they can apply it. Because the last thing you want to do is actually do vMotion and then turn around and have to fix everything when it gets to the other side. So that's important. Now you also have to have this problem, right? You have to turn around and create a network tunnel. Because for a period of time, communication to that VM may essentially exist on the left-hand side as opposed to the right-hand side. And two is that VM wants to be able to communicate across to its peers. So you want to establish a network tunnel so that you can maintain VM communication both from the outside world to that VM and the VM across both of those. And then you migrate the VMs, right? And you migrate them in the order that you want to. And in the end, you have to, for those virtual machines, reverse the replication, right? So all of those steps in orchestration are important to be done in order for you to be able to do an orderly, repeatable migration. Once you've done that, the VMs are running at the second site, and you can go home. Okay, so that's an example of what we think a zero downtime data center migration is. And the work that we're doing in place is to put into place all of those facilities for you to move forward. One of the biggest problems that we find today in SRM is really this IP reconfiguration. Because if you move a virtual machine from Site 1 to Site 2, then you really can't, in most cases, you can't maintain that same IP address. You have to do some IP reconfiguration. The interesting thing that we found is recently we surveyed our SRM customers, and we found that 40% of the customers today are forced to re-IP the VMs, right? If you re-IP a VM, you got to restart it. But there's a significant part of the customers who aren't doing that, right? What are they doing? Well, luckily, if their sites are nearby, then they stretch the VLAN. Or two is, many other customers turn around and say, I don't stretch the VLAN, I reserve the same VLAN at Site 1 as on Site 2. So the result is the fact that I can maintain that IP address from Site 1 to Site 2. Okay? Existing solutions for stretching VLANs work in smaller distances. And what I mean by smaller distances, I'm talking about 50 or 100 miles, right? And in some cases, you'll turn around and some people will feel comfortable stretching a VLAN within a building. Other people will feel comfortable stretching a VLAN within a campus. Some people will feel comfortable stretching a VLAN over a metropolitan area. There are a lot of solutions that are being developed by the industry so that you can get rid of the IP configuration issue. And the example are products such as Cisco OTV, et cetera. There are products that VMware is actually working on or thinking of developing, which are in the situation of providing essentially a virtual layer 2 stitching between two sites so that you can essentially get a homogeneous network across that. Yes, sir. Is that back-to-back? We'll leave it at that, yes. Okay. Yes. Okay. That's a VMware employee, so I'm not sure if that's an advertising for a feature that we're developing or he just asked me a question. Okay. No problem at all. Now you get this next piece, and we'll talk about what is the Geo Data Center. Why would I want to vMotion VMs between two data centers? Why don't I just take HA and stretch it between two sites? Okay? There's a lot of conveniences there, right? The convenience is that failover is automagic, right? You don't have to worry about building a recovery plan, right? HA takes care of it. It fits into it. There are a lot of challenges, though. One is the storage challenge, right? If you have, for example, active-passive replication, such as SRDF, et cetera, then that's not something that will automatically work if I turn around and say, because at any point in time, if I have active on one side and passive on the other, I have to bring up that LUN on the other side. right? So it's a lot of work and storage challenges. There are products coming out there and recent announcements from various storage vendors that talk about active storage. That is, data storage that are mirrored over a long period, over a long distance, and allows you to have access from both sides. So those are examples, but there are some issues there that we need to take a look at. And there was a recent KB article that comes out, and we have VMware has a KB article for both NetApp Metro Cluster as well as EMC vPlex that talks about using HA, high availability, in those stretched environments. The other thing you got to deal with is, if you lose 50% of your capacity, is that considered an availability event or a disaster? How many of your data centers can actually deal with, oomph, I've just lost that? Because we're not talking about maybe 10 VMs, 20 VMs. I've lost essentially 500 of my VMs, right? Do you really want to, within your organization, turn around and say, look, I'm going to take out 50% of my workload, and I will allow an automatic failover, versus in the past what I needed to have is I needed to have an executive within the company declaring it as a disaster. So one of the things that we're looking at is maybe we can do this from a technical basis, but we also need to take a look at what it means, what the impact in your data center is. And for those of you who've been running, clusters for a period of time, when you happen to have these types of disasters that take out 3 nodes, 4 nodes out of an 8 or 9 or 10 node cluster, then how does that impact your environment, et cetera? There are other new requirements. Other requirements are test failover, right? At some point in time, you're going to not necessarily trust the documentation. You're going to want to test it. And at some point in time, being able to turn around and say, hey, I have this test infrastructure that happens to be a pretty sophisticated cluster, a pretty sophisticated storage, pretty sophisticated networking gear, in order for me to do a test and dev system, I really want to be able to test it in an operational system. You have to deal with multi-site admission control. How do you guarantee that I have the right resources in the right place in order to ensure that I can guarantee availability? And the last thing is improve reporting. Sooner or later, when something hits the fan and you are responsible for availability, you want to turn around and somebody has to say, what happened? And you surely don't want to give your boss 10 gigabytes of log files and say, somewhere's in there it told me exactly what occurred. You really would like to have a report that says, there was a failure, this is the type of failure, this is the action that occurred, and here's the remedial action. So we see that as a critical part of being able to support the Geo data center. And those are the types of things that we're looking at. And it's worth noting, right? I mean, for many of you, depending on the distance between your 2 data centers, then definitely you're looking at metro clustering, and this is, we're just simply using metropolitan clustering or stretch clustering, or SRM and vSphere and replication, and taking a look at what happens, right? Hardware independence at a failover site, that comes magically because of the fact of VMware and virtualization. Now, realistically, that's not quite correct, because if you're using advanced features from of some of the server platforms, then there's a lot of cases of saying trying to keep homogeneous nodes across 2 sites. You may turn around and say, look, I'm going to keep the hardware platforms that are 3 years old, I'll keep them at the DR site, and I'll keep the brand new spanking things at the primary site. In this case, if you're trying to build a cluster, then that will restrict the types of features that you can have. Something for you to take a look at. Consolidation to reduce cost. The nice part about being able to create a stretch cluster in a lot of ways is that a stretch cluster allows you to use resources more seamlessly across 2 sites. Long distance DR, anything greater than 100 kilometers today, it's technology that's not there. A lot of people are talking about potential technologies. There's still a lot of areas with regards to, can I provide data consistency across that? Automated runbooks and workflows not available today. If I stretch a cluster, that's an area that we need to deal with and provide solutions for. Fast, reliable RTO. Metro, that one there's an X on that side. There really is our goal within, whether it's HA or whether it's SRM, in order to provide that type of basis. Non-disruptive testing is not available today in a high availability cluster. It's something we need to work on in the future. And then centralized management of DR. If you take a look at it from a DR basis, that's something that we have to also work on. Okay, the next thing we want to take a look at, the last thing, is BCDR as a service, right? If you start taking a look at it, how many of you today, when you decide who determines what the DR strategy is, how many of you, it's determined by the application owner? Okay. How many of you is determined by the vSphere admin? Okay, for the rest of you, who determines what the DR protection is for a specific application set? It's political, okay? No, it's good. There's an interesting cut here, which is who defines if something is DR protected. 2 is what the RTO is, what the RPO is, right? Decrease the RPO, increase the storage cost, increase the networking cost. And of course, I liked it at one point in time. I was giving a presentation to an executive, and the executive said, "You made my life very difficult." And I said, "What do you mean?" He said, "In the past, an application owner came to me and said, I need to DR protect my application." And he said, "That's easy. It's $4 million," because that was the cost of the hardware and everything else. And he said, the person left, and my job was done. Now, with virtualization, you actually have a cookbook of potential solutions with a various cost. Well, what type of replication do you want to have? Do you want it synchronous? Do you want it asynchronous? Do you want to have an RPO of 1 hour? It changes dramatically the way in which you take a look at things. And so you're right, which is one of the goals is how do you remove the OpEx in setting up BCDR? So one of the things that we're looking at, and for those of you looked, we've recently announced vCloud Director, and says, how do we use the cloud as a potential DR infrastructure, right? There are a lot of cases that you potentially have a DR site today. Your DR sites may be a high-cost item. Is there a way in which we can start using either from an internal basis or externally make use of resources in order to decrease your cost of DR? So two examples here. One is you provide DR as a service, and 2 is you place the application owners into an organization, right? So you place them into what's called a VDC, virtual data center. And you can define, in this case here, I define green, and I don't know what color shows up, orange on your side. And you define green and orange and say, okay, the green one will not be DR protected, the orange one will. So depending on where they provision this application, then automatically the intent would be that the vSphere facilities would automatically set up the DR for you. So the end is, if I lose, in this case here, I may lose the entire data center, but what will happen is that it will automatically move to that central service on the right and restore them. The benefit of where we're moving to is to try to remove the amount of work that needs to be done in order for you to set up DR. Because if you start taking a look at this, what have we done? Today, when you provision a virtual machine, in the past you would hand provision it. We gave you templates. Now, if you start looking at vCloud Director, it gives you the ability of having self-service provisioning. That's great. Now they have self-service provisioning. The next step is how do you make sure that they do self-service DR? Now, trust me, we know that the amount of work that needs to be done to be able to set up consistency groups, to set up the whole replication environment is not a walk in the park. There's a lot of work that we need to do in order to accomplish that, but that's really what our vision is, that you allow your end users to define and say, what are the policies? You export those as essentially virtual data centers, and then everything else is accomplished from there. The second thing that we take a look at is, what if you remove, so on the previous slide, the cloud on the right was your own DR setup. It was using your facilities, right? What if we move and say the cloud on the right is actually a service provider that has provided multi-tenant access, and it gives you the ability of being able to say, look, I happen to have my own internal cloud sites or my internal clouds, and what I want to do is be able to turn around and use other facilities. So just like you're looking at service providers to be able to provide you additional facilities within the cloud for cloud burst, here's a good example where one of the things we're looking at is to use service providers at being able to provide more economical DR sites. Why? If you actually take a look at the number of times that you do DR, most companies, most of you will essentially have a career within your company and never have to actually have gone through an actual DR environment. When you start taking a look at that investment, how do you reduce that investment? Definitely using a service is an ideal place to deal with. So in the end, one of the things we're really looking at as well is how we move to a policy. One of the things that we're trying to understand is, do you give somebody a VDC and say, okay, either the VDC is DR protected or not, or do you provide the ability for somebody to turn around and say, look, I'm going to give you a certain set of policies that allow you to decide and say. So, for example, in this case here, I happen to have a group of VMs, which may be a VApp or a container that says, okay, these are not DR protected at all. The second one is a critical group and says your RPO is 15 minutes. And then finally, you have another one on the bottom, which is essentially your RPO is 12 hours. So you can start to hand pick where these applications go. So really we see SRM being able to help you with regards to storage selection. It picks which data stores that VM needs to be on, ensures that they're replicated, ensures that the replication meets the targeted RPO. Two is it'll automatically configure protection groups. Protection groups is a VMware term. Consistency groups is typically what's used with regards to storage. You decide whether or not it kind of fits into place. And then three is it automatically assigns virtual machines based on your predefined policies to recovery plan. So the goal is to continue to reduce the OpEx. So what I've shown in the last couple of slides is two possible approaches that we're looking at. One is a very large environment that says, hey, you define a VDC and you decide whether it's going to be DR protected or not. The second one says you give you a little bit more granularity that allows you on a per VM basis and say, what policy do you want to have? We're spending a lot of time with customers and trying to figure out what's the right granularity that provides the flexibility you need to have, but also the simplicity in the automation so that you can continue to move forward from there. So if you take a look at this, right, there definitely is, SRM is something that we provided a lot of good value to. There are a lot of customers who will turn around and say, you know, it's not just add water. If you're planning how to do disaster recovery, or if you're planning BCDR, it really is trying to sit down and take a look at your applications and what your goals are there. There were other sessions, and of course it's Tuesday afternoon, and I cannot remember. I was going to add on there which ones are tomorrow and Thursday, but there's a long series of sessions. I know that, for example, there actually is two other sessions, Failback and More. There's a detailed one that's happening tomorrow, if I remember. So it will go through all of the steps that automated failback would look to. So it'll give you a good insight of what you can plan on as you're developing the next level of Site Recovery Manager. Two is there's a deep dive session as well on host-based replication that will explain it in much more detail than I have. So that becomes a very important part. And also there's a customer session that talks about Lone Star College and as well Warehouser, which is a great use case of how SRM could actually be used for data center migration. So in the end, what we take a look at these takeaways. One is make sure that virtualization makes DR possible. Site Recovery Manager is possible because of virtualization. Two is SRM really orchestrates your disaster. It really kind of connects all the pieces together. And really, where we're moving towards with Site Recovery Manager is a few things. One is going way beyond disaster recovery, dealing with virtual machine mobility. Two is the ability of being able to reduce a lot of the workflow that you need to deal with. And three is to start dealing with sites not only for DR in the case of a disaster, but also the flexibility and agility of moving virtual machines across. Okay? And with that, I'll be glad to answer questions that we have. Thank you.